I'm going to take you through our data collection for the enzyme lab. Remember, what we are doing here is we are looking at an enzyme called catalase. Catalase breaks down hydrogen peroxide, and hydrogen peroxide is made in your cells. It is a byproduct of metabolism, so, but it is harmful to your cells. And this is the case with almost all living things. Everything has catalase in order to break down hydrogen peroxide. So we could get catalase from a number of places, but we're going to do catalase from yeast. So in your science kit, you have a little baggie of yeast that we're going to be using. You also need some hydrogen peroxide. So you could pick this up from school, or you could find your own hydrogen peroxide. You also need your pipettes. Those are these things, little eyedroppers called pipettes. You also need from your science kit the graduated cylinders. Well, there's one, the graduated cylinder. You also need the thermometer. And then some things of your own that you need to gather. You need some kind of string to tie to the thermometer. I actually used dental floss and it worked great. We're going to need to measure the temperature inside the graduated cylinder. So that's why we're doing that. We need a little bit of dish soap. Whatever kind of soap you have at your house is fine. You're going to need a tiny bit of sugar, a quarter teaspoon. If you don't have sugar, you could use something else with sugar in it, honey, something like that. And you're going to need some hot water and cold water. So I have ice water here, and hot water you could get by just seeing how hot you can get out of the tap, or if you have, you could heat it on the stove. Just don't get it so hot that you burn yourself. Yeah, is that all? And then some various cups and bowls will also come in handy. So gather your materials, and then the first thing you're going to want to do is make your yeast solution, because it's best if that sits for about 15 minutes before we start using it. So that's going to be your first priority. So to make your yeast solution, you're going to measure out 50 milliliters of warm water. You can use your graduated cylinder to do that. Not super hot, just warm out of the tap is perfect. And you're going to pour that into some kind of bowl or cup where you're going to make your yeast solution. I've already made mine, so I'm just reenacting here. So add your 50 milliliters of warm water. Then you're going to need to measure out a quarter teaspoon of yeast. So I have some measuring spoons at my house, but the smallest I had was a half teaspoon. So I was just careful to try and get as close as I could, a half of a half, which is a quarter. So add your quarter teaspoon, stir it up. And then these yeast are living organisms. They belong to the kingdom fungi, just like mushrooms. So they will be happier if we give them some food. So we're going to give them a little bit of sugar, just 1/8 of a teaspoon of sugar, a tiny little bit. Add that in there, stir it around, and let that sit for about 15 minutes. In the meantime, you have a lot of other things to prepare, so we'll probably be ready by the time you are. Okay, another thing that you need to prepare is your soap solution. So you don't need a lot. You're only going to be adding 3 drops of this to each trial that we do, and you're going to do probably 4 trials. So you don't need a lot of it. Just put a squirt of dish soap or whatever soap you can find into a bowl and add about equal parts water. Add the same amount of water, stir it up. Now you have some soap solution. Okay, and then I think we are ready to start collecting data. So you are going to be using your graduated cylinder to collect your data. If you're watching this video, what you are going to be changing is the temperature. So we're going to see what effect temperature has on the activity of our catalase enzyme that comes from our yeast. So basically we're going to add our hydrogen peroxide and our yeast together each time at different temperatures and see how that affects the rate of the reaction. And remember, the rate of the reaction, this hydrogen peroxide is broken down into water, H2O, and oxygen, O2 gas. So we'll be able to see the product of this reaction in the form of gas, in the form of bubbles. So we're going to measure the size of our column of bubbles that we get above our solution. Okay, so the first thing is to make our solution, and we need to get it at a certain temperature. So I'm going to start with the cold. I've got some ice water in this bowl. I'm going to submerge this in the ice water. And maybe not yet because it's starting to float. I'm going to put some stuff in it first. So we are actually going to dilute our hydrogen peroxide. It doesn't need to be 3%. We're going to dilute it by 50%. So we're going to be working with 1.5% hydrogen peroxide solution, since this in the bottle is already 3. Okay, so let's think about the pipettes that we're going to use here. So we want to be careful that this reaction happens inside our container and not inside the pipette before we are ready. So I have a pipette that I'm going to have just for my hydrogen peroxide. I have one that's going with my yeast. I have one that is going with my soap solution. Oh, and you do need some water. I might not have mentioned that before. I have one that is going with my water. So for our first one, actually for all of these, we're going to add 6 milliliters of hydrogen peroxide and 6 milliliters of water and 3 milliliters of our yeast catalase solution. It's only the temperature that will be different. So when you measure, it's best to measure with the pipettes. You can be pretty accurate with these. Notice that they are marked on here. You probably can't see it on the video, but on your real pipette, they're marked 1 milliliters, 2 milliliters, and 3 milliliters. And the half milliliters are marked as well. So use that to measure. It's going to be easier than trying to measure in the graduated cylinder. So 6, you squeeze it really tight. If you're lucky, you can get a whole 3 milliliters in one go. I did it. So that's 3. 6 milliliters of hydrogen peroxide. I'm going to add 6 milliliters of water. 3 and 6. Now, before I do anything else, I need to get this down to a cooler temperature. So now I'm going to put this in my water bath here. This is in ice water. I'm going to add the thermometer, and I'm going to wait 3 minutes. I'm trying to cool down my hydrogen peroxide and water. So I'm going to start my stopwatch. Wait 3 minutes. Okay, I am at 3 minutes. So next I'm going to record my temperature. We're going to record this in degrees Celsius. So I am at 11 degrees Celsius. So I will record that in the data table. You record your own temperature. And then we're going to add some soap solution. So this, we don't need much. I'm just going to add 3 drops. The purpose of our soap solution is to just help us catch those bubbles a little bit more so we can see them more easily. I am very gently going to pick this up and swirl it just a little bit. I don't want to make any bubbles on top. I want all the bubbles that are in here to be a result of the chemical reaction that's happening, not my swirling. And now we're ready to add our 3 milliliters of catalase or yeast solution. If yours has settled, you want to stir it before you do that. Get 3 milliliters. And now when I add this, I still don't want to add any bubbles. So what I'm going to do is pick it up, tilt it, and squirt on the side of the graduated cylinder so that it doesn't disturb the liquid down below. Now I'm going to put it back in our cold water and again wait 3 minutes before I measure how much bubbles we have. So wait 3 minutes, one more time. Okay, it's been 3 minutes, so I'm now going to measure the volume of my bubbles in my graduated cylinder. So let me show you what this looks like here. I used a Sharpie to mark every 5 because I was having trouble seeing that. That's actually a good tip on the pipettes as well. If you're having trouble seeing any of the markings, you can go over them with a Sharpie. So I'm going to look at this very carefully. We have, our markings are down to the millimeter. So I'm going to try my best to estimate between markings and measure to the 10th of a millimeter, which is hard because you have to measure where it starts and where it ends. I think I've got 1, 6, I'm going to go with 7.5 milliliters of bubbles, just measuring the bubbles. If it's easier, you can measure the total volume and then measure the volume of liquid and subtract it. You'll probably get a better answer that way. So that's how you're going to measure your bubbles. You're going to record that in your data table next to that temperature that we took earlier. So now you are going to do this 3 more times. So 4 times altogether at 4 different temperatures. Make sure each time that you rinse out your graduated cylinder between so that you don't have any of the ingredients still in there. So I would suggest doing 1 in the cold water, ice water, 1 at room temperature, so you don't, yeah, never mind. 1 cold, 1 room temperature, and maybe 2 temperatures of hot water, 1 a little bit hot, 1 hotter. Be careful with the hot water, please. Don't burn yourself. It does not have to be boiling hot to make this work. Just 1 a little bit warm and 1 warmer, maybe I should say. So get 4 different temperatures, and then you're going to submit your data using the Google form that is linked on this document as well. I think that's all. Okay.